So we have this circuit here, and we're going to go over like what exactly the circuit's doing. So this is another type of counter, but this counter, when it resets at a certain value, when it reaches a certain value, it's supposed to reset. So that's what this load is supposed to do. When this load is 1, and this load will be 1 when QO and Q2 are both 1, because then 1 gets fed into this AND gate, and this AND gate, so this AND gate will need to spit out a display 1 for load to be 1, and when load is 1, this whole thing gets resetted. So let's see when this value occurs. So so initially everything's at 0. So this is 0, this is 0, and then this is 0. So 0, 0, 0. So that's just 0. Now, next is 0, 0, 1. Okay, so that's 0, 0, 1, and this is just 1. Next is 0, 1, 0. Wait, okay, so when we're here, we see 0 and 1 are fed in, but the AND gate will just spit out 0. Now we see when it's 0, 1, 0, that's just a 2. But the AND gate is gonna display 0. Now when it's and the change is happening every time clock reaches its rising edge when clock is 1. Okay, just to point that out. Next it's 0, 1, 1. So that's a 3. Okay. So again, AND gate spits out 0, so it's not going to be resetted yet. Next, it's 1, 0, 0. So that's a 4, and still the AND gate is still going to give out 0. The last one is actually 1, 0, 1, and that's a 5. And we see there's a 1 here and 1 here, so the NAND gate will give out 1. Okay, and now since the load is 1, this whole thing is going to be resetted back to 0. Okay, so we see this counter stops counting at 5, and then when it reaches 5, it goes back to 0. And this is called a modulo, a 6 modulo counter, because it can display 6 different numbers: 0, 1, 2, 3, 4, and 5.